Howdy, this is Mr. Potter. In today's video, I want to go into the 11s, but I want to talk about it from the standards of a debugging standpoint. If you're trying to debug something, you want to be able to do things over and over again, and you want to be able to do them quickly, and you also want to get some feedback. And the idea of getting feedback is why we usually have this Boolean I am debugging, which we can set to true or we can set to false. And that's what I've got here. I've got the 11 simulation file open, and what this 11 simulation file does is it allows us to play multiple games, but the computer does the playing for us. And so I want to analyze this 11 simulation, and I want to talk about how we're going to tweak our 11s board to be able to play the game for us. So we've got this private static final int games to play as 1. Right now it's set to 1. We can change this to play 10,000 games or 100,000 games if we want to find out percentages, or we can just play it once and kind of see, is it going through the rules correctly. And I've got this private static final Boolean I am debugging, which is currently set to true. The idea is that if it's true, it's going to give us a lot more feedback. If it's false, then it's not going to give us as much feedback. It's just going to give us the information that we desperately need. And this is the main method. This is our first real main method that we've got for the programs we've been dealing with in this unit. So we create an instance of an 11s board. And I am primarily sticking with an 11s board, although I could make that just a regular board. I'm setting my count of wins to 0, and I'm setting up a for loop. So int k gets 0, k less than games to play, k plus plus, so that games to play value that we had set up here at the top. And if I am debugging that we're going to print out the board, then while board.play if possible, and this is something new. The idea is that we're going to want the board to play itself, to actually go through a play. And if that's true, and if I am debugging, then we're going to print out the state of the board. And as long as the play is possible, then we're going to make a play. After we've gone through this while loop, there aren't going to be any more plays possible, either because the cards don't allow a play, in which case we've lost, or because all the cards have been used up, in which case we've won. And if the board has the game as one state, then we're going to increment the wins, and then we're going to start over. And we're going to keep doing this inside this loop as many times as games to play is set. And then we're going to go ahead and set up a percent 1. So we've got 1,000 times wins divided by games to play plus 0.5 divided by 10. And of course, there's some little trickery going on here. I want to make sure that I actually get a double. I want to make sure that I don't have a divide by 0 error. I want to take care of rounding issues. So 6.5% will round up to 7%, and I'm casting the result as an int. So I know I'm multiplying by 1,000 and dividing by 10. That's really multiplying by 100, but it makes sure that I take care of decimal places along the way. I'm incrementing games to play plus 0.5, and I'm taking this quotient and adding 0.5. This just makes sure that it rounds correctly. I could use math.round if I wanted to, but that also returns a double, and I'm looking for an int here. I'm looking for an integer %1. So I'm going to print the games 1, print the games play, and print the play the %1. So what I need to do is I actually need to work on this. The game is one method we've already talked about. If all the cards in our array are null, then we've won the game. But I want to talk about this play if possible. So I want to go to our 11s board, and I want to look at the methods that we wrote. Now we wrote contains Jack, Queen, King, and that basically returns us a Boolean. So it's either true or it's false. What I really want to do is I want to say, I don't want to contain a Jack, Queen, King. I actually want to play a Jack, Queen, King. Or actually, I want to find a Jack, Queen, King. And I don't want to just know, does it exist? I actually want to find out what positions it's in. So I'm going to create a list of type integer. And that's what I'm going to return. So we're going to make a little bit of a tweak here. I'm going to get rid of this if selected size is less than 3, return false, because I actually want to return the thing is, this selected cards may be just the 3 cards that were selected by the player, or it may be all 9 cards that's being sent by the computer to see if there is a Jack, Queen, King to be found. What I'm going to do is, because I need to return a list, I'm going to create a list of type integer, and we're going to call it cards to return, and it's going to be a new array list of type integer. And the idea is that I want to, instead of returning a Jack, Queen, King, I actually want to return that cards to return. And 2 things are going to happen. Either I'm going to return an empty array list, in which case the size is 0 and I know that there are no cards in it. Or I'm going to return an array list which has 3 elements: the position of the jack, the position of the queen, and the position of the king. And I can remove those elements from my set. I can basically draw new cards to replace those. So instead of having a Boolean jack is false, queen is false, king is false, I actually want to have an int, because these are going to be the positions. And because these are positions in an array, I'm going to start them at -1. So jack is -1, queen is -1, and king is -1. And I'm going to go through all the selected cards, get the card out of a particular spot, and if the rank is equal to that jack, then I want to say jack gets I, because I want the position that the jack is in. And if the rank is equal to queen, then queen is I. And if the rank is equal to king, then king gets I. And so when I've gone through this loop, either jack, queen, and king are all -1s, or jack, queen, and king are the respective positions that they're in. And so what I can do now is I can say if jack is greater than -1 and queen is greater than -1 and king is greater than -1, then I can add those elements to the array list. So I can say cards to return dot add, and remember that array lists deal with classes, not primitive. So I really need to do new integer jack, and I want to do the same thing with queens and kings. So we're going to go ahead and just copy paste, make this queen, and make this king. And no matter what, I want to return the array list. But I only want to add to it if I actually have a jack and I have a queen and I have a king. If I don't have all 3, then I want to keep an empty array list. So this is actually going to return an array list that's either empty with size 0, or it's going to return an array list with the 3 cards, the 3 positions. And so that means that I need to tweak this is legal. So if selected cards size is equal to 3, and here this is find Jack, Queen, King dot selected cards, and I want to know if its size is equal to 3. In other words, when I run selected cards on this, do I get a size that's equal to 3? And down here, if another play is possible, I don't want to know if it just contains a Jack, Queen, and King. I want to know if find Jack, Queen, King selective cards dot size is equal to 3. So I have to make these tweaks to is legal and another play is possible, because these methods, is legal and another play is possible, these are methods that we have to override for board to work. And so I need to make sure that it works for the methods that we're dealing with. So we're going to go down here to contains pair sum 11, and we're going to do the same changes. So again, I don't want this to be contains, I actually want to find it. And because I'm trying to find it, I'd like to know the location of it. So we're going to say a list of type integer. And we're going to go through. Again, I'm not going to take care of this if selected cards dot size is less than 2, return false, because if I'm trying to find all possible pairs, or at least one possible pair, I'm going to be given the entire array here. So what I'm going to do is just create an array list of type integer, and I'm going to say cards to return, just like we did before. And this is going to get a new array list of type integer. And then I'm still calling on C1 and C2. I'm still going to create 2 cards. I'm still going to go through the list, find all the possible cards. And if their point values add up to 11, I don't want to return true. What I want to do is I want to add both of those positions to my array list. So I'm going to say cards to return dot add, and that's going to be a new integer, and the position is position I, because card I is this C1 that we're dealing with. And then cards to return dot add new integer j, because j is the other position where the card 2 is located at. And then once I have this pair, I actually want to immediately return cards to return because I want to make sure I don't want to add anything else to this list. I only want one pair because that one pair is going to be processed. And then down here, if I've made it through, I still want to return cards to return. Because I'm supposed to be returning an array list or a list of type integer, but this list is going to be an empty list. So instead of having contains pair of sum 11, we're going to find a pair sum 11. And we're going to either return the location of one such pair that adds up to 11, or we're going to return an empty list. And as we did before, we're going to modify another pair as possible. We're going to modify is legal to take care of that. So for is legal, we had selected cards size is 2, and instead of contains pair sum 11, we want to find pair sum 11. And I want to make sure that its size is equal to 2. I need to make sure I make this a method as well, just to work out correctly. And then for another play is possible, I do need to check it as well. So this is going to, instead of contains pair sum 11, it's going to find pair sum 11. And I want to make sure its size is equal to 2. And so if one of them is equal to 2 or the other one's equal to 3, then we're going to go ahead and do this. So we're going to compile this just to make sure that we don't have any horrible errors in our 11s board. Everything seems to work okay. But we're not done yet. I've got this 11 simulation, and we never have run this method play if possible. The idea of a play if possible is that I want to physically play the game. I want to physically have the board play itself, which means I need to go back to my board class, and I need to use these methods that we have here. This idea that I want to replace the selected cards, the cards that work out to a pair, the cards that work out to a jack, queen, king. I want to physically replace those cards with new cards. And we've got this card indexes, which gets all of the possible cards. So we're going to write this method called make play as possible. So here we have another play is possible. I need to actually write a play if possible method. So what we're going to do is we're going to say a public void play if possible. And notice that our method here is just a default method. There's no parameter here. And we're going to play if possible. So the first thing I need to do is I need to get an array list of type integer of positions, gets new, and I don't actually want a new array list. I actually want to get a list of all the card indexes. So this card indexes is what we're going to need. So card indexes. So this is going to be all the possible positions. And then I'm going to say list sub integer playable cards gets, and I'm going to call on find Jack, Queen, King for positions. And then if playable cards dot size is equal to 3, in other words, if it truly is a Jack, Queen, King pair, then we want to play those cards. So we're going to go back to our board and make sure that those cards are done using the replace selected cards for our selected card. So we're going to replace selected cards for the playable cards. And at this point, we've played that thing. So now we can say else then we can go over here and say playable. And actually, at this point, I would want to return as well, because if that's true, then we made a play, and we want to return. And then I'm going to go ahead and say, okay, well, if I'm at this point, I did not have a Jack, Queen, King, so now I need to check for a pair. So we're going to say playable cards gets find pair sum 11 for our positions. And then if playable cards dot size is equal to 2, then we want to replace selected cards for playable cards. And we can call on return as well, but it really doesn't matter at this point. What we've done is we've made a play if it's possible. So we found all of the positions that currently have cards. We use the card indexes method to get those from the board class. We've got playable cards as a list of type integer, which is going to find the Jack, Queen, King positions. And if there are a Jack, Queen, King triplet, then we're going to go ahead and replace those cards with new cards and return. Then we say, okay, I must not have a Jack, Queen, King triplet if I reach this point in the method. So now let's see if we have a pair that sums to 11. And if we do, then we can return. And if I reach this point, I don't have to say return because it's the end of the method. But at this point, there's no such play possible. So I'm just putting that there just to notice that no play is possible. Let's make sure that works fine, which it does. So at this point, I should be able to compile this 11 simulation. There is an incompatible type. Let's figure that out real quick. So, oh, okay. So I don't want this to be a void. I actually want this to be a Boolean. So at this point, if I reach this point, I want to return true. I knew there was a reason I was putting the return in there. And at this point, I want to return true because I have made a play. But if I reach this point, there was no play to make, so I'm going to return false. So let's try that. That'll be a little bit better. So let's compile this. And we'll run it. And this should take us through one simulation of the game, and it should actually show us the plays that it's making. So let's click in here and scroll up. So we started off with 8, Queen, 7, 8, 10, Ace, Ace, 9, 5, and there's one play that we can make that's card 4 and 5. The 10 and the Ace add up to 11. So we replace card 4 and 5 that get to 7 and the 8. And at this point, nothing adds up to 11, and I don't have a Jack, Queen, King, so the game ends at this point. Let's try running it again. And this one gets a couple of plays in here, but I still haven't won. So looking at this, I've got a 4, 9, Queen, Ace, 6, Queen, 4, King, 10. And when I get down here, it looks like the 10 and the Ace got replaced, cards 3 and 10. And so I get to this point, and I've got a 9 and a 2, so cards 1 and 8 get replaced, and nothing works. So I see that it's doing that. I still haven't seen it replace a Jack, Queen, King, which would be nice. Nothing there as well. I want to see it replace a Jack, Queen, King. That's what I really want to see to make sure it works. Oh, that looks good, except I reached a null pointer exception. So we do need to deal with that. And of course, this is why we have the debug flag set up so that we can see issues like that. So let's analyze this game and see what exactly happened. So scrolling up to the top, here is the first thing, and I notice the first cards that change is this 4 and this 7 changed to a 10 and a king. And then I go down here, and this king, queen, and jack get replaced. So king, queen, and jack appears to work. And it looks like it's going through these well, except I do reach a point where I'm starting to get towards the end state of the game. And that's this end state of the game where I have a null. Now there are plenty of spaces to get here. I could do the 7 and the 4. I could do this 10 and the A state, the 8 and the 3. The 6 and the 5. All of these cards were actually playable, and I actually would have won this game if I didn't run into this null pointer exception for the fine pair sum 11. And the reason is because this object here, null, this is a null object, so it's not going to have access to the method. So I actually need to kind of watch out for that when I call on methods. So we're going to go ahead and pop back. So let's see. Our board, when we add card indices, it should not be adding it to the list here, but for some reason it is. So let's go ahead and cover it on our end. The thing is, if I get this card at sub I, and if C1 equals null, then I really want to continue. The idea behind the continue is that if I hit that spot, then I don't want to deal with that card, because that card's not going to work. It's not going to have access to any methods. I'm not going to be able to get its point value, which was the problem, line 111. And similarly here, I'm going to want to say something like, if C2 is equal to null, then continue. And I'm going to run into that same issue with Jack, Queen, King. I just never got that far. So we're going to go ahead and do that. So if C is equal to null, continue. And that's just going to continue through the next iteration of this loop. And I'm hoping that will take care of that. So let's run the simulation again. I'm hoping to get another good simulation that gets deep into the nulls. That didn't. That didn't. That didn't. And of course, y'all remember from when we played earlier, it can take quite a few games. It took us 17 tries to win a game, and we almost won that game, except except for the null pointer exception just a few minutes ago. That would have been our third trial. That looked so good, and yet something didn't work. The thing is, the 9 and the 2 should have worked, the 10 and the A shouldn't work, and it didn't. That's heartbreaking. So let's take a look at that and see if we can fix that from our 11s. This is obviously it's an issue with our find some pair of 11. So let's go back up to that method, because it's clearly not getting through all of those cards. So we're getting the cards from the selected cards, and this is actually being done through play if possible for positions. So I really should, if what was my Boolean called again? I am debugging. So if I am debugging, then we want to print the card indices. We want to print those positions. So I'm going to have to set up some type of loop to do that. For int I get 0, I is less than positions dot size I plus plus, and we're going to system dot out dot print positions dot get I, and that's going to give us the card at that spot, and then system dot out dot print line, and then that this will actually close for the if. So get rid of that close brace and move this close brace over, and then I want to set I am debugging to true, because I am. So I am debugging. We're going to go ahead and set that to true. So we're going to compile this. And we're going to run the 11 simulations. So I should have a few more things. Oh, it's just printing 1, 2, 3, 4, 5, 6, 7, 8. I really want to print the contents of the board. I want to print the card at that spot. So let's do that then. mistakes. So I want to print that card at position sub get I. So let's compile that. And we'll run. And again, I want to run a game where I get deep into the nulls at the end of the game, which isn't happening yet. That looked good. And so we got to this point where we had the 2 of diamonds, the 7 of diamonds, the 4 of spades, and the 9 of clubs. I should have been able to put the 9 and the 2 together. I should have been able to put the 7 and the 4 together. And for some reason, it wasn't seeing that as a pair. So I'm going to go ahead and minimize this just so I can keep track of what the output was at this point. Because for some reason, it's not reaching all of those cards. So this is our play if possible. We got there. And this is doing replace selected cards. So obviously we weren't getting any good result from this. So we actually need to put some debug statements in here. So card C1, C2, and card 1. And if C1 is equal to null, then continue. And I'm wondering if I put the continue in here, that was the problem. So let me do this. I'm going to go ahead and pull that out. I don't want to put this if statement here. And I'm not going to have this if statement here. What I'm going to do is I'm going to take care of short circuiting here. So I'm going to say if C1 is not equal to null and C2 is not equal to null and C1 point value dot C2 point value is equal to 11. So that way, if it's null, then I break out. If this is null, I break out. If I hit this point, then I'm not going to have the null pointer exception that we were dealing with. So let's go ahead and run this again. And looks like I got pretty far. Let me scroll this up so I can see more of my output. I started getting into the nulls. The ace and the 10 should have worked. The 6 and the 5 should have worked. The 3 and the 8 should have worked. And didn't. So I'm going to pause at this point, and I'm going to see if I can find the mistake, and as soon as I find it, I will come back and show you what I found. Alright, so I think I figured out what the issue is. And the issue is, notice that our nulls are always at the beginning of the list. It's almost like we're not getting to these cards at the end. And that's because I'm starting at 0 and only going up to the size. So I may be getting 0, 1, 2, 3, but I'm not getting card 0, card 1, card 2, card 3. And that's going to be a problem. The thing is, I is the index of this loop. I really should be the ith element of this selected cards. So this really should be selected cards dot get whatever is at I. And similarly, this card 2, it's going to have to be selected cards dot get whatever's at J. And so that's going to be an issue. And I'm going to need to tweak these down here. The cards that I want to return, it's going to have to be, I can just do, I don't have to create it as a new integer. I can just do selected cards dot get I and selected cards dot get J. So I'm wondering if that will work. Let's try that. That seems to work. And if we run that, and again, I want to find a run where I'm getting null deep into the nulls. So let's scroll back up here. So over here, I've got the ace and the 10 got removed. Over here, I've got a 7 and a 4 that got removed. And then I had, let's see, scroll down a little bit more, and I can see that the 7 here and the 4 here got removed. But I want to get a run that goes pretty deep into the nulls. That was the issue that I was having. So let's go ahead and run this again. And of course, being able to see the deck and being able to see the state of the game at every point, that's really why we have these I am debugging Boolean variables in there to make sure that this works. And that looks pretty good. We got to a point where we had all nulls. The last cards that we had were the 8 of hearts and 3 of spades, and it looks wonderful. So I'm going to go back to my 11s board, and I'm going to change that Boolean I am debugging back to false. And I'm going to do the same thing for my 11 simulation, changing its I am debugging to false, because I'm pretty sure that it works the way that I'm expecting. And so if I run, notice it's just going to tell me the status of one game. What I could do is I could change this to 1,000 and see what happens when I run 1,000 games. And of course, the nice thing about a computer is that it can do this fairly fast. I've got a winning percentage of about 12.2. I can even up that up to 10,000. Have it run 10,000 trials. And this time I wasn't as lucky. I only won 10.6% of the games. Remember that these are based on random luck, and so I do expect that percentage to waver a bit. But as I increase the number of games that I'm playing, I'm going to see that kind of smooth out towards the tendency, and you'll see that about 10 to 12% of the time you're going to win. I was just extremely unlucky that first time I played 17 games and only won once. So, I hope you've enjoyed this little excursion through the 11s. I do encourage you to go through the 13s the same way, and also take this opportunity to invent your own card games, or read a good book on card games and come up with a program that, now that we've got the foundations for not only the GUI, but how to simulate and how to write rules for a card game, I encourage you to write your own. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.